Welcome to today's podcast episode, where we're diving into the groundbreaking world of space exploration, specifically focusing on the Apollo-11 mission. You know, it's fascinating to think about how far we've come in technology since that historic moment of landing humans on the moon in 1969. So let's start by unpacking the Apollo Guidance Computer, or AGC, which played a crucial role in this epic journey. Imagine being tasked with guiding a spacecraft to the moon without the modern conveniences we take for granted today, like smartphones or GPS. The AGC was essentially the brain of the operation, managing everything from navigation to control for both the command module and the lunar module. What's particularly intriguing about the Apollo-11 AGC source code is that it has recently been digitized and made accessible for everyone to explore. The team at Virtual AGC and the MIT Museum worked tirelessly to bring this historic code back to life. It's like discovering a hidden treasure chest of programming that made lunar maneuvers possible. Now let's consider the significance of the names given to the AGC programs. We have Comanche 055 for the command module and Luminary 099 for the lunar module. These names are not just arbitrary labels, they reflect the pioneering spirit of the people who developed them. Comanche, a nod to the indigenous people known for their skill and grace, symbolizes the precision needed for space travel. Luminary, meaning a source of light, aptly names the module that would shepherd humans into the unknown. Speaking of the developers, let's highlight a remarkable figure, Margaret H. Hamilton. She was the lead programmer for the AGC. Her contributions are monumental, and it's said that her team often worked under intense pressure, needing to ensure the software could handle high-stakes conditions reliably. Just imagine programming a spacecraft with less computing power than a modern-day calculator. What also stands out is the collaborative effort involved in creating this technology. The program was prepared under NASA's Manned Spacecraft Center and involved contributors from various roles that ensured every line of code was scrutinized and approved. Can you visualize the teamwork that was required? It wasn't just a group of coders, it was astronauts, engineers, and scientists all working together toward a common goal, which becomes even more impressive considering the complexities of rocket science. Now, if you'd been in charge of programming for one of the missions, what would you have done differently? Would you have added additional features, or perhaps different navigational checks? It's interesting to think about how much risk was involved and how each decision could lead to either soaring success or potential disaster. As we wrap up, it's clear that the Apollo-11 mission wasn't just a technological triumph. It was a showcase of human ingenuity, collaboration, and courage. The AGC's legacy continues to inspire modern technology and space exploration. Before we go, I encourage you all to reflect on how far we've evolved in technology and what the future holds for space exploration. What are your thoughts on sending humans to Mars, or perhaps establishing a permanent base on the moon? That's a wrap for today's discussion. Thank you for tuning in and exploring the incredible story behind the Apollo-11 mission with us. Keep wondering about the universe, and until next time, stay curious.